What has disappeared, first of all, is the belief in the power of reason to know things. And second of all, knowing things out there in the world stopped being desirable. Other things have become desirable. And so, as you said, why should we be concerned with science? Why should we not become mystics out there in the mountains, uh, basically torturing ourselves to get into higher realm? Why not? And ultimately, Popper has no argument against this.
Last week, Aviram Rothschild and I discussed many of the flaws of the scientific method of Richard Feynman. We also discussed how those flaws were emblematic of the way physicists approach physics today. During this episode of Inductica, we're going to go deeper and look into the philosophers of science who influenced minds like Richard Feynman and still influence the way physicists think about the scientific process today. Joining me is Arkadiusz Synowczyk. Ark is a philosopher, he's a senior editor at Intellect, and he's a friend of Inductica. His areas of interest reside in epistemology, philosophy of language, and philosophy of science, with a particular interest in the problem of induction and the practical applications of philosophy. Besides his academic activities, he runs a YouTube channel, Epagogist, and he will soon launch his Substack blog, Induction in Rush. Arkadiusz is a fellow inductivist, a fellow adherent to the inductive method, and so I'm excited to have him on the program. How you doing, Arkadiusz?
It's a pleasure to be here. It's quite hot on my side, but the pleasure of being here is just compensating for all of this.
Yeah, and it's unfortunately it's hot here in Phoenix as well, and so you can probably hear our air conditioning blowing as hard as possible. Do you at least have air conditioning there?
A little bit of, yeah,
Oh
but it's,
God!
it's
Oh
not
man!
as effective as yours and not as effective as I wish it were.
Yeah, right, right. Well, hopefully we can keep your mind off of it. Let's start with Karl Popper. So Karl Popper is a very influential philosopher of science. And to start us off, Ark, why don't you tell us a summary of the views of Karl Popper?
Okay, so Karl Popper, in essence, the starting point of Karl Popper is that we can't prove our scientific hypotheses or theories. However, we can try to falsify them. We can criticize them, first of all, because the main point of Popper is that we can criticize things. And one of the, I think, the single most important method of criticism that Popper singles out is falsification, which consists of, first of all, coming up with a hypothesis in a psychologically non-logical way. This is just an insight, a creative intuition that you have. So when you have it, you try to deduce some observational predictions from that hypothesis, and then you simply check whether those predictions obtain or not. If they don't obtain, your theory has been falsified. If they do obtain, your theory has been corroborated. Importantly, we should distinguish this from confirmation. It has been corroborated, not confirmed, and therefore should be preferred, accepted, and further tested. If we have conflicting hypotheses that have been both corroborated, we should prefer that which has more explanatory or predictive power, meaning it explains more phenomena, more things in the world rather than less.
So we can see that this is this is probably very everything we've just heard is probably very familiar to a lot of people, even if they've never heard Karl Popper's name. We've heard that scientific theories should be falsifiable in order to make them scientific. There has to be a way to, there has to be some kind of evidence you could uncover that would eventually, falsify it in principle. And, the second thesis, science is never proven. All you can do is fail to reject. That's the best you can do. And once you fail to reject, then it's corroborated or it's preferred now. Now, what would you say is, in what ways would you say that Popper has influenced the way that scientists think? And I would especially ask that you focus on the way he has influenced physicists. But of course, if you find other branches of science and his influence interesting, you can bring that up as well.
Okay, so let me start by distinguishing between Popper as he really is and as how people have read him, because I think this is a very distinct matter, and we'll come back to this. And here I will focus on Popper's influence insofar as people have read and interpreted him. And another thing that I will start with is that Popper is generally regarded as one of the most influential and greatest philosophers of science of the 20th century. And we can easily see that in how often he is referenced by various scientists, very often in their popular accounts of science. And how has Popper, as he has been perceived, influenced science? One of the major ways in which he influenced science, unfortunately, is very negative. And the influence of Popper has been to encourage premature hypothesizing. Because let's elaborate a bit on what I've said in the beginning. According to Popper, and not only, this is not something that he invented, many philosophers thought, and some still think, though not so much as back in the days, that the process of coming up with a hypothesis is a non-rational process, meaning it is not subject to rational evaluation. It's simply a psychological, non-logical process where you have some hunch, some insight, and there's nothing that logic can do here. We can test it afterwards, but there's no method to guide the method of coming up with hypothesis. This has changed a little bit in the last decades in philosophy of science, but Popper's influence here and that of others still holds. And so, as I said, because of that, Popper has encouraged premature hypothesizing, because we can't subject our method of hypothesizing to rational norms. So we simply have a hunch, we simply have a background. And what's more, by putting emphasis on testing, people in scientific journals have been asked to basically start with a hypothesis, make predictions, and afterwards check whether those predictions hold. And this is an insight that is elaborated by Edwin Locke in his work on induction. And he gave a great example, because he gave an example of himself where he subjected an article to a journal where he didn't want to theorize, he wanted to simply ask some interesting questions and do research. And there was a big backlash. And for people who don't know, submitting an article and review process is anonymous, so people on the other side don't know whom they are evaluating. So the reviewers accused, in this case, Locke, that he doesn't know the theory that he developed decades ago and that he's expert in. And yeah. So
yeah, I mean, for those who don't know, Edwin Locke is a very well-known and well-regarded psychologist. I mean, I don't know myself. I haven't read his work myself, but he is well known and well regarded. So it's funny that he would be, that he would catch so much criticism during this anonymous process, and that further he would be accused of not knowing his own theory.
Yeah. So for context, Edwin Locke is an organizational industrial psychologist, and he's a legend in his field, basically. So to summarize, Popper's approach has resulted in premature theorizing because people basically demand from you hypothesis, hypothesize, and test. That's it. However, that's not the only influence.
Yeah, and to remark on another concrete example of this, Sabine Hausenfelder remarks that in particle physics, they're simply testing random hypotheses, and these tests continue to get more and more expensive, and there's no basis on which to prefer some hypotheses to be invested in versus others. It's just, oh well, I creatively came up with this, and let's see if this particular hypothesis explains the results we're talking about. And she criticizes this process as scientifically dubious, but also quite expensive.
Exactly. And that's an influence of Popper, but not only. It's a result of a dichotomy that exists in philosophy of science between the process of discovery and the process of justification. So on the one hand, we have the process of coming up with a theory, and that is not subject to rational evaluation and guidance. And then we have testing, confirming of the theory, and those are distinct processes. This was a very, very much entrenched assumption in the philosophy of science back in the days. It has been significantly rejected in the past decades, but this hasn't influenced scientists, I think.
Yeah. Something I'll add to this is that my own theory of induction, which is available for Patreon supporters, my own theory of induction gives detailed standards that a hypothesis must meet before it is even entertained. And so my theory of induction gives very specific norms for the process of discovery, and those norms for the process of discovery are considered to be extremely linked, not separate, but it very intimately linked with the norms for proving a proposition. So this is in strong contrast, at least to my own theory of induction.
We'll be talking about Kuhn, for example, today too, and he was one of the most significant figures who rejected this dichotomy, which is a bit interesting. But let's move on to further influences of Popper. In general, that emphasis on testing neglects other way in which we gain support for our theories and hypotheses. This neglects, for example, the sheer explanatory value of a theory. So, for example, when Copernicus started theorizing on what is the configuration of the planetary system, he didn't start by simply making up a hunch and then trying some predictions. He saw how well a certain idea explains what he already knows, and he already saw in that confirmation of what he had in mind. And so this approach neglects this, and we see this, for example, in how people think about quantum mechanics. People defend, for example, the Copenhagen approach and not trying other approaches by saying, but you don't have any other observational predictions. You haven't created any broader theory. You can't test your theory in any way. So what are you talking about? And this neglects the issue of whether different theories about how the world works at the quantum level, how those fare with respect to their explanatory value.
Yeah. So to concretize specifically, so actually, a lot of the comments on my video about the ether, I make a video explaining how we know that there is, in fact, an ether in physics. A lot of the comments basically said, this is garbage, what you're saying, because it's garbage or it's useless or it's unscientific, because a lot of comments said this because, and this is Popper's influence, because it doesn't make any predictions that are different from the mainstream theory. And that's true. And eventually, yeah, in order to really be practical, I mean, whatever replaces quantum mechanics and general relativity is going to need to give us an understanding of new phenomena. That is what is going to be its ultimate mark of success. But in the meantime, just as Copernicus could look at the sky and see, wait a second, the planets, they're not going around the Earth straightforwardly. They're doing this loop-de-loop pattern. That seems to be a lot more simply explained by the idea that the planets are moving around the sun rather than moving around us. This loop-de-loop is caused by the fact that they're moving around the sun, not around us. So Copernicus was able to make that hypothesis based on evidence and reasoning, even though that hypothesis at the time didn't make any different predictions. It, of course, did eventually, but it was worth entertaining at the time, of course, that this theory might be right. And of course, in the means, and then when it comes to the ether, we already know there's an ether, regardless of whether it makes further predictions. So something else I would add is that the ability to make additional predictions is not the only thing science is about. We are able to know that there is an ether just based on what is known already, and to dismiss that just because it doesn't make additional predictions is to simply neuter yourself scientifically. You're basically saying, I'm only going to believe the results of basic deductive logic, basic inference from the observations we have so far. I'm only going to believe such inferences only if it generates new predictions. It neuters you. It really reduces the amount of power you have for identifying new facts about the world. So that's just in way of concretizing some of the things that you were saying, Arkadiusz. What was the next thing you wanted to get to?
The next thing I wanted to do is mention the last influence that I have in mind right now is that first let me say that what you and me have said seconds ago, it is influence of Popper, but not only. There has been a long tradition of philosophers advocating ideas that either suggest or imply such an approach, and this goes back to people like logical positivists or even Ernst Mach in the 19th century. So this is absolutely not a new idea, but Popper was definitely one of the most influential figures in terms of entrenching further that approach and assumption. And the last thing that I would like to mention in terms of Popper's influence is that Popper and others whom I have singled out a second ago have made scientists very unconfident and skeptical. When I speak to scientists and look at their research, they are very overly uncertain in what they do, and such lack of confidence results in a lack of ambition. People who doubt themselves in terms of their capacities to reason don't try to hit the stars, so to speak, get to the stars, and instead they focus on some very specific minutiae details in very restricted fields of research. There's not at all an attempt to present something grander. And part of the reason why this is so is because of the skepticism that has been entrenched by philosophers going back at least to the 19th century.
Yeah, that I've definitely experienced that myself. I once talked to a physicist and I told him, hey, I have this idea for reformulating calculus without limits. So like conceptualizing calculus without using the concept of a limit. This is an idea I've been playing with for a while. And without hearing anything more, he immediately just had this kind of affect, which was just super doubtful, just like, yeah, I mean, he said something along the lines of like that sounds like a waste of time. He said something like that. I'm like, well, why is that? And it wasn't even because he particularly doubted me, although fair enough, like, a fundamental, useful reformulation of calculus would be an enormous achievement. But before someone gives you any indication of what they're talking about, it's unscientific to doubt them, unless they're saying something that just seems to make no sense, which maybe calculus without limits seemed to make no sense to him. But it seemed more that what he was reacting to was, who are you to do something like that? You're just a guy. You're not Newton. You're not Einstein. You're just some guy. Like, you can't reformulate calculus. It's like, well, how do you know I'm just some guy, number one? Number two, like, again, it's unscientific to just simply assume this, and it shows a certain lack of confidence in himself. Like, he's just some guy also. And I mean, and this guy was actually, I should say, a very diligent, disciplined physicist. He always gave extremely clear answers to a lot of my questions. This is when I was in his class a couple years ago, and it's just that lack of confidence is just very. It's too bad, because this guy, I feel like he deserved some confidence based on on the virtues that he did have. Now, moving on to another fundamental question here. How would you contrast Popper's approach to the inductive method, especially the aspects of the inductive method as developed by Aristotle, Bacon, and Herschel?
Let me start by saying that, in a way, there is no such thing as the inductive method, because there are simply different ideas on how inductive reasoning should proceed. But let's say I will provide my own views and refer to how other figures like Bacon, let's say, viewed this. So the first difference that strikes me is that people like Bacon or Aristotle have emphasized to a very significant degree the pre-hypothesis stage, the stage where you simply gather data, look at the world, try things out, ask maybe some questions that are not yet hypotheses, but simply interesting questions. Oh, what will happen if I do this, if I do that? What's going on if this would be destroyed, or something like this? And we see that in actual practice, for example, in Charles Darwin's work, who took literally decades before he presented the evolutionary theory to the world. He has been simply gathering data, gathering observations going around the world, having some ideas, but being very careful here. And Popper's approach simply asks you, come up with a hypothesis and test it. And this is not how the inductive method, as I think it should be understood, looks like.
Yeah, right. That's something else, is to note that simply hypothesis is just, when you look at the history of science, hypothesis does not account for, like, it doesn't even account for, like, a majority of the kinds of questions that scientists ask. And so, we've all been raised, I don't know about you who was raised in Poland, but in America, we are all raised under the hypothetico-deductive method. It is just really cooked into our scientific intuitions for how that is the way science works. So what I hear you saying is that a major point of contrast between the general inductive method and Popper's method, the method that's generally accepted today, is the emphasis on simply making observations and asking questions rather than testing hypotheses. What other contrasts would you draw between the inductive method and and Popper's method. Now, what I take to be, you said there is no particular one inductive method. What I mean when I say inductive method is I mean philosophies of science which emphasize observation, inference from those observations, and the formation of generalizations at the end. So to make that concrete. To make that concrete, let's say Kepler, let's say astronomers start by observing the heavens. Kepler identifies a pattern in the motion of the heavens. I'm skipping lots of steps here, but Kepler identifies some patterns that the planets move in ellipses. Then Newton, using inference, Newton identifies the causes of that particular pattern of motion, which is the gravitational attraction between the planets and the sun. And the end result of each of these steps of effort is a generalization. Planets move in ellipses, or matter attracts all other matter. These are generalizations which we come to at the end as a result of a chain of observations and inferences. Each observation being based on knowledge that came before, and each inference reasoning only with inferences. Each inference being based only on conclusions which have been proven earlier. So that's what I generally mean by the inductive method. First of all, would you agree with that general characterization of the inductive method?
Yes, I would agree with this general characterization, and
okay.
I would develop what you have said and say that the inductive method, in contrast to what Popper speaks about, is much broader.
Mm-hmm.
What Popper says neglects many aspects of how science works. So we said about it neglects the period of pre-hypothesization. And in that line, it neglects such a thing as the process of concept formation, which is also a crucial process that only after a significant amount of time results in you being able to state new hypotheses with those new concepts, ask new questions, make new predictions. Popper's approach also neglects other kinds of inference that we have not mentioned, because we have basically mentioned explanatory reasoning, explaining things, reaching to causes based on their effects, predicting the general behavior of things. But there are also other kinds of reasoning, like analogical reasoning. So Popper's method simply leaves a lot of stuff out of how science and the inductive method really looks like in practice.
Yeah. One example that comes to mind of this is that in early biology, it was absolutely crucial for categories of living things to be established. And it was crucial for those categories to be understood rightly. So, for example, should that be classified along with a rat, or should it be classified along with a bird? Now, in the modern day, we know that it needs to be classified along with a rat. But back in Aristotle's day, most of his fellow Greeks would probably find it very strange to classify a bat along with a rat instead of with a bird. And so the process of properly categorizing is this step that's very crucial. And we can see that, and part of what I would say is we can see this crucial step. We can see the importance of this step and getting this step right in the lack of rigor of modern psychology. In modern psychology, the terms have not been well defined. We have terms that mix things together that are not of the same kind. So, for example, ADHD is one of my particular pet peeves, because this includes all different kinds of people with all different kinds of problems. All it says about them is they have trouble focusing. But a lack of focus can be caused by a myriad of different things. Perhaps some actual, local deficiency of the ability to focus. It can be caused by depression because, you're just not motivated to focus. It can be caused by anxiety. Your mind's too crowded to focus. It can be caused by all these other things. So we're just blending together all of these things that are not necessarily similar to one another. And I think psychology especially is rife with these misconceptualizations. And Popper's method gives psychologists no guidance on how to correct this situation. It's just, oh, well, let's just make hypotheses. Never mind if we're identifying those hypotheses using terms that consistently identify the facts in a way that actually allows you to know what the hell you're talking about. Just test some hypotheses. So it simply doesn't give us guidance for huge portions of the scientific process. Other comments on the difference between the inductive method versus Popper's hypothetico-deductive method?
Not so much. I would simply add the example of the early developments of chemistry. A lot of work has been done in the early developments of chemistry, and not only in the early developments, has been simply a work on how to classify substances. And I would also add that I spoke about the issue of confidence, and I think Popper's method and the inductive method differ in that respect too, although Popper also tries to encourage you. So he says, even though you can't really know what the world is like, be ambitious, try things out. How it works out in practice and whether it's consistent overall with what he says is another issue. But as I see things, this is a comment I really wanted to make, is that one of the main tasks of a philosopher of science that I see is working on very fundamental things like giving you advice as to whether you have a fundamental capacity to grasp a world or not. And that alone has huge consequences for scientific research. And being confident is a very simple method. It's nothing like some calculus, let's say probability calculus, but it does have significant effect on your research. And it's not an accident that physics reached such heights, and it was developed during the Enlightenment and the Renaissance, when there was a significant belief in the power of reason to grasp reality, while sciences like psychology have been developed in the 19th century, where in philosophy we see a rampant skepticism in terms of what Kant said, what Hegel was saying in the 19th century, but also mainstream philosophy has often spoken of the three masters of doubt, great figures of the 19th century like Nietzsche, Marx, and Freud, all of whom had significantly skeptical leanings. And so it's not an accident that physics has developed in this period and reached heights, while psychology and other sciences developed in the 19th century. And there's a lot still to correct and to work on, to speak the least.
Yeah, for sure. That is definitely one of our goals here on Inductica, is to not just do what Popper did, which is like, go out there and be ambitious, son. You got it. It's like, well, yeah, sure, but let's give you the actual reason to be ambitious. Let's give you the actual reason to have that confidence, because otherwise, it's like, okay, yeah, you can do it. You can believe in yourself. It's like, well, why? Like,
exactly.
We're gonna if like should you try to have confidence and to get and to make great predictions? I mean, if you can't, if the skeptics are right, then the lifestyle of kind of an unambitious scientist is the logical lifestyle. I'm going to get tenure. I'm going to do the bare minimum required. I'm going to have a beer when I get home. I'm going to focus on my family. Whatever else it is, that's now the logical path instead of being the next Newton. So, like, if the skeptics are right, then you're not going to be the next Newton. It actually is a stupid idea to try and reformulate the fundamentals of calculus, even if you think you can do it, because, well, who are you? So let's see. Now, here's a question I wanted to ask. I've heard that Karl Popper, well, I've more than just heard about this, but I've heard a lecture, at the last OCON, Mike Mazza gave a lecture at the last Objectivist conference. This is an intellectual conference I go to for Ayn Rand's philosophy. At the last Objectivist conference I went to, Mike Mazza gave a presentation about Karl Popper, and he said that Popper was skeptical about induction as such. Can you tell us a little bit about why Popper was skeptical of induction and what alternative he offers? Well, we already know the alternative he offers. Let me take the question this way. Why was he skeptical of induction, and how was his method, his hypothetico-deductive method, presented as an alternative?
So let me start by clarifying how I use the term induction. By induction, as many contemporary philosophers of science, I simply mean any kind of non-deductive inference. So
that's what they mean. That's what they mean by induction.
They and me too, at least in how I use that term here.
Interesting. Okay.
And if we classify things in this way, the fundamental difference between deduction and induction is that in deduction, you basically explicate in a way what's already there. It was in the premises, and it has to follow as a matter of very simple deductive matter of consistency. Whereas in induction, you reach something genuinely new, what is not simply deductively contained in your premises. And so in deduction, you can't have true premises and false conclusion. In induction, this can occur. And Popper's reason for being skeptical of induction as such has been basically this. And this is a source because of which basically all philosophers who criticize induction have any skeptical doubts about it. That's why they have doubts about induction, in that they have inherited deduction as the model of reasoning, and then there is an issue of how can induction work if it's not like deduction. Of course, we can see that here they are making an, I would say, unjustifiable assumption in privileging deduction, requiring all reasoning to be like deduction. But the fundamental reason for why Popper and others are skeptical or have doubts about induction is that conclusion in induction doesn't simply follow out of the premises as it does in deduction. And so they have been influenced by Hume here, who also pointed this out and made it's not accident that this is called Hume's problem of induction.
Right.
And after pointing out that conclusion in induction doesn't simply follow from premises, they make the following argument. They start by pointing out that inductive conclusion doesn't simply follow deductively from the premises. And so they say, therefore, we need some kind of a bridge. We need some rule that will make our inductive reasoning like deduction. So, for example, we take the rule things in the future will be like things in the past. Or we take the probability calculus and then apply it to our premises. They try to make some kind of a bridge that's going to make induction like deduction. And then they point out, okay, let's say you come up with some kind of a bridge. It's going to be some kind of a rule or a set of rules. But how can you justify that set of rules? If you are trying to justify inductive inferences here, how can you justify those rules without relying on induction? Are those rules self-evident? No, the probability calculus or any kind of other method is not self-evident. Although here we may debate as to what's the status of probability calculus, but the bridge between premises and induction are not self-evident. They are not known a priori. They are not known either deductively or nor they are simply self-evident. And so your only method is some kind of induction, but you can't use induction to justify induction. Therefore, it's the end. And that's the main reason why they have worries about induction and why Popper had, but those are not the only reasons. Popper was more sophisticated than this. So, first of all, Popper pointed out that this argument that I presented excludes not only inductive conclusions being certain, but even probable. Because and let's proceed to the argument. Let's say you have inductive conclusion that is probable. You would have to deduce it from the premises that it is probable. However, you can't deduce the fact that the conclusion is probable from the premises, and so you need some kind of a bridge that will entail deductively that your conclusion is probable in even, let's say, a fraction of a degree. And then the same problem applies. You have some rule which you can't justify because you can't use induction to justify induction, nor are there any other means to solve this problem. So Popper's conclusion in the end is that not only you can't prove your theories and hypotheses, you can't have the slightest reason to think they are true. There is no such thing as evidence. And to shock you further... Yeah.
Okay, we'll get back to that. Go ahead. I'll get back to this. There's no such thing as evidence. But to shock us further, what's going to shock us further than that?
Let's notice, and that's something that Popper also notices, is that if there is no such thing as evidence as such, there is no such thing as evidence for, nor evidence against. If you can't have evidence as such that X has occurred, you can't have evidence that X hasn't occurred, and therefore, strictly speaking, you can't falsify your hypothesis. To falsify your hypothesis, you would have to have evidence that confirms what has happened during experimentation. You would also have to know that your equipment has been working properly and that no other conflicting explanations are relevant here. And since you can't have any evidence as such, you can't even disprove anything. For Popper, you can't have any reason for something nor against it in the slightest degree, and therefore Popper is a complete skeptic, which people usually, I would say almost always completely miss, even if they are philosophers teaching philosophy of science class.
Okay, now, so let's go back to the original claim that he doesn't think there's any such thing as evidence. What do you mean by that exactly? What does he take the word evidence to mean, and what's his reason for thinking there is no such thing? And then there's a lot more questions after that, but let's start there.
By evidence here, I mainly have in mind inductive evidence, because we can speak of deductive evidence where things follow as a matter of deduction, but here he also says ultimately we can't know anything. And you asked me to explicate what do I mean by evidence, what does he mean by evidence. And the challenge of the argument that I have presented in a way is to explicate the concept of evidence. And so it's difficult, first of all, to answer it and then to do so in some neutral way that doesn't involve my personal views. But let's say that by evidence, I mean a case where some piece of knowledge, some piece of information points to, directs to, suggests some other piece of information. And so according to Popper, because of the argument that I presented, this can't be the case. We can't have anything point to anything else. We can't have this in a psychological sense. Things can seem true, or seem to be the case in some slight degree, but there is no such thing as evidence. And another way to answer this is when we ask Popper what does he mean by evidence, is he could say, I don't know, and that's the point. I can make sense of how deduction works, but because of the argument which I have given you, I can't even make sense of such a concept as evidence. So it's not a question for me, it's a question for you. What do you mean by evidence?
So okay, this is interesting. It's starting to take form for me now. His deeper beliefs and his deeper skepticism is starting to coalesce for me. So he thinks deduction is fine. He thinks deduction, you can actually arrive at correct conclusions, but there's nothing to deduce from, because deduction has to start with some kind of premise that you're certain of. And so there's no way to go from observation to some kind of premise. There's no evidence. There's no such thing as evidence. So as a result, this wipes out all knowledge. Now I have to ask, this is hardly the most, I'm going to catch him on an apparent inconsistency here, which is not the most important thing, I think, in philosophy. Philosophers love to, you were inconsistent with yourself. Yeah, I don't think that's the most important thing, but I'm going to start with that anyway. There's no such thing as evidence against something. So, doesn't that wipe out his whole method and his whole standard of science, which is that a theory must be falsifiable? Can't we just not falsify something? So what did he say? Did he say anything to address this glaring self-contradiction?
And here I don't think he has a genuine answer here, and that he has a genuine problem here. Namely, he can't give us any reason. Since there is no such thing as evidence, he can't give us evidence for his theory. That's the end. Yeah, but
he can't give us a deduction either, because there's nothing to deduce from into his theory. So it's just a bunch of words. Like, his book is just a bunch of words, according to him.
Yes, and I think, even though I haven't read Popper say this, I think from his approach and the arguments that he gives, deduction is also without any evidential force. As I said, in the end, he is a total skeptic. There is no such thing as evidence for anything in any kind of way. But, and I will try to imagine what he would say, because I can't give exact statements of his here. But in the end, the answer to this problem is that, okay, we can't know anything nor give any reasons, but we want to do science, so we have to hypothesize. So, and that's what I came up with. If you see some problems with it, state those reasons. Maybe we will come up with some better methods. But all we can do is try. And
reasons, like, well, what would be a reason versus a non-reason? What would be better versus non-better? Like, I think this theory is better because it will lead to the election of Donald Trump. And he's like, well, and then he could respond like, well, that's not scientific. I'm like, well, whatever, dude. Like, it's whatever I want now. It's it's so frustrating, this stuff, because like skeptical philosophy has really just blown everything up. And something I should say, fundamental philosophy is not one of the goals of this channel, although we might do some stuff on it occasionally. But it's really important to note that all of the philosophy of science rests upon fundamental epistemology, fundamental questions of, well, how do we even know anything? Do we even know anything? And although I won't be doing technical work on those questions, I have to acknowledge that all of my work relies on fundamental correct answers to those questions. Fundamental correct answers to those questions. And I do believe those questions have been answered in the affirmative. I do believe we can know things. I do believe there's a specific way of knowing things. It specifically involves gaining sensory evidence for things, the details of which I won't go into, but I do believe that the senses really give us data about reality. And 2 books that I can recommend to the audience for a cure to your skepticism, an argument for how you know reality, how you can know reality, by what means can you know reality. Here are the 2 books. First is Objectivism, the Philosophy of Ayn Rand. This is a book by Leonard Peikoff, Objectivism, the Philosophy of Ayn Rand. And then a second book I recommend that gives an inductive argument, sort of a more step-by-step argument for how we can know reality, is A Validation of Knowledge by Ron Pizzaturo. So you can go on Amazon and buy either of those. Ron Pizzaturo's book, I believe, is only on Amazon. That's A Validation of Knowledge. So that's what I would recommend for those who want to get into these deeper philosophical questions. Because as we've just seen, your answers to these fundamental philosophical questions condition whether the rest of the scientific venture is even possible. And, Popper is a skeptic on epistemology generally. And so there becomes a question like, what purpose does your scientific method even serve if you don't even think knowledge is possible to begin with? If you're just a skeptic, it's just a very bankrupt theory, it seems.
There is this approach. I'm not so much sure as to whether this is the exact way as to how Popper would respond, though that's probably so. However, this approach is called a pragmatic solution to the problem of induction. So we can't prove anything by induction, nor give any reasons, inductive reasons that are genuine reasons. But if you want to get anywhere, we have to try. That's basically the argument.
Okay.
Yeah. So and it's very simple. Induction is basically trying. If we don't try, we are basically guaranteed to fail. If we try, then at least we have any kind of chance. We are not actually acting against ourselves and disrupting.
Okay, I guess. Well, but why try? But like, why? But aren't there other things in life to worry about other than identifying scientific facts. Like I said, there are real alternatives. You can just be a, just instead of being an ambitious researcher, you can just focus on teaching your students. Of course, what are you teaching them? You don't even know if you're teaching them something correct. But, you can focus on making a paycheck, keeping the students happy, keeping your boss happy, providing for your family, this kind of thing. Just focus your efforts on other legitimate pursuits other than science and actually knowing anything. So I don't think this works even as a meager encouragement to scientists after they've been discouraged by skepticism.
Exactly. And you've asked a very interesting question, because there is one way in which I'm sure that Popper tries to give arguments for his theory, and it's by trying to give ethical reasons. Ultimately, the ultimate argument for Popper's views in philosophy of science are ethical arguments as to what do we want to achieve in life. And why do we need criticism? Why do we need falsification? And those arguments are ethical. However, we simply run in a circle. We give ethical arguments for which we say we can't give any ultimately reasons. So.
Oh, yeah, right. Yeah, that doesn't get him out. That's very fascinating, because I think ultimately science does rely on ethics, because there's the question of, like, why are you doing any of this? There has to be some kind of good that comes from it, and that good, but those claims to the good themselves rest on epistemic claims. So someone could come around with his skepticism and say, okay, sure, like, I'm glad you want to do good, but what's your evidence that the good actually exists? Oh, you said there's no such thing as evidence, so the good's out also.
Exactly. And David Harriman, in his lecture series on the history of physics, it's, I think, still available by vandamacademy.com, he states two reasons as to why science disappeared in the Middle Ages. And I think he is right here. And he singles out that what has disappeared, first of all, is the belief in the power of reason to know things. And second of all, knowing things out there in the world stopped being desirable. Other things have become desirable. And so, as you said, why should we be concerned with science? Why should we not become mystics out there in the mountains, basically torturing ourselves to get into higher realm? Why not? And ultimately, Popper has no argument against this.
Alrighty. So that was a summary of Karl Popper and our views on him, and I think we covered him quite well there. Let's move on to Thomas Kuhn. So Thomas Kuhn is another philosopher who has been very influential on scientists in the last century. So, Ark, why don't you give us a summary of the views of Thomas Kuhn?
Okay, so Thomas Kuhn, as probably many of you know, is famous for such a term as paradigm. However, with time, he stopped using that term in favor of other terms. And the most important terms here that I will single out is disciplinary matrix. And that's basically the same thing that he meant by the term paradigm, meaning metaphysical beliefs, epistemological values, methods, some exemplary scientific solutions to scientific problems, things like this. And the other term is lexicon, which is basically your system of language. And first and foremost, I think Kuhn was a historian of science. He did have philosophical views, but he's most famous for basically historical claims. And so, according to Kuhn, the history of science has been as follows. First of all, we start with pre-science, where we have no disciplinary matrix at all. At most, we have attempts at a matrix or
Real
fights.
quick, what is a paradigm or a disciplinary matrix? A lot of people have heard that word, but they probably don't know exactly what a paradigm means. And actually, I don't think I know technically. I'm sure you could teach me something about it.
Okay, so both paradigm and disciplinary matrix is basically your theoretical background. And Kuhn gives examples of paradigm and disciplinary matrix as follows. Those are, for example, scientific generalizations. Those are your metaphysical beliefs. Those are epistemological rules that you accept. Those are exemplary solutions to scientific problems, like Copernicus' solution to the problem of how the planetary system looks like. Things like this. So a general theoretical background that informs your scientific practice. And so as the first thing, we have pre-science, where we have no disciplinary matrix. Then we have immature science, where we have different disciplinary matrices that compete against each other. After some time, one of those wins out and is adopted, at least, and is simply adopted. Then we have the stage of normal science, which he also called mop-up work, where we basically apply our paradigm, our disciplinary matrix to various problems. We develop our theories further, not and all inside that general approach that we accept. We simply develop this further, find some new anomalies that we haven't expected, and we account for those anomalies in terms of our disciplinary matrix. After time, however, various anomalies gather. There are some things that you can't simply account for with your disciplinary matrix. And with time, as those anomalies reach sufficient number and sufficient significance, you have a crisis. You start to doubt that your current disciplinary matrix will account for those anomalies, and people start to search for alternatives. This results in revolutionary science, where a new disciplinary matrix is developed and solves those problems, at least a significant amount of those, because according to Kuhn, a new disciplinary matrix can develop while not accounting for everything, being in some way deficient against the old way of doing things. And so then the cycle repeats itself, at least so far to this day.
Now, could you give a concrete example of each stage of this life cycle as Kuhn would see it?
Okay.
Now, what I mean by this is that, like, I don't think this would. I disagree with this way of framing the whole thing. So I don't think there's actual examples. But give me what Kuhn would take to be an example of this.
Okay, so let's start with pre-science. An example of pre-science can be a primitive society, but doesn't have to be a primitive society. It can be an advanced society that isn't simply interested in certain phenomena. Then, as to immature science, let's say we have a primitive society that starts to develop various conflicting approaches as to how to solve things. Let's say we have different schools of alchemy. And then we have chemists who have a different approach. So that's an example of this. Then some approach wins out, and we have normal science. So let's say we have Copernicus, who solves the problem of how the planetary system is configured, and then people try to and then people simply accept what he said and try to develop this further. They may try to solve some problems that Copernicus missed, make new predictions. When they find some celestial body that seems to contradict Copernicus, they try to account for that anomaly in terms of his theory. A crisis.
So this is very important, by the way. So this is very important. So like, part of what Kuhn is saying is that when apparent contradictions to the theory arise, these people are not going to acknowledge that maybe they're wrong. They're gonna try and fit it into their theory. Is part of how he thinks this will work. They're gonna try and fit it in somehow.
Yes, in normal science, their default approach is simply, let's try to account for all of those things in terms of the old theory. Okay. So I gave the example of early science where we have conflicting disciplinary matrices as, let's say, alchemists versus chemists having different approaches, or even various schools of alchemy where we don't have chemistry yet. So we can have different schools of alchemy, let's say, and then we have a period where things stabilize. So let's say we have the 17th and 18th century where chemists group substances and make some basic observations and formulate basic laws about them. Then we have crisis. As an example of crisis, I gave an example of Ptolemy, where anomalies against his theory accumulate, Earth being small in comparison to the whole universe. In general, giving some strange predictions as to how planets behave in terms of going westward and then turning eastward and going like this for some time and then repeating this. So anomalies accumulate, and then we have Copernicus coming back, giving an exemplary solution. We have a revolution where older astronomers propose this, younger ones are eager, the Copernican approach becomes more popular, and then old ones die out, and we have Copernicus reigning. Yeah.
And so that gets us, and so that gets us as an example of what Kuhn called normal science. How would you say it proceeds from there? Again, we're giving an example of what Kuhn would take to be the different aspects of his scientific life cycle. His paradigm life cycle. So what would come next? It would be something along the lines of like, okay, now you have Newton and Galileo, and you have, by using this paradigm of the Earth-centered universe, and like mechanical laws, you have tons of work being done, getting all kinds of stuff done, figuring out the laws of motion, figuring out the laws of kinematics, and all of this would be very, productive, and it would all be within the paradigm of an a sun-centered universe, a sun-centered solar system, and everything acting in accordance with certain mechanical, mathematical laws. And that would be, would that be an example of what Kuhn called normal science?
Yeah, people simply working according to a given solution. And afterwards, either there are various possibilities, civilization can die out, or people simply may not find some, they may not make new developments, or the cycle will repeat itself. So we have culmination after Copernicus with Newton, and then we have Einstein saying something different about gravity, and so we have so the cycle repeats itself. And whether something
so like there might be particular, and he would, Kuhn would point out, not to say that this is a correct characterization of history, but this is just so that the audience can understand what Kuhn is talking about here. Kuhn would point out that there'd be certain crises. So, for example, I think the failure of the Michelson-Morley experiment to detect motion through the ether, that would be considered a crisis. Perhaps the strange perihelion of Mercury, the fact that Mercury doesn't move quite in line with the way that Newtonian mechanics predicts, like that would be a small crisis. And then this new paradigm, Einstein's relativistic perspective would come and just completely change the way we think about all of that. And then we would get into, and now in the modern day, we're in this realm of a new paradigm where we have a new kind of normal period of normal science where people are working in accordance with that paradigm. Would that be an accurate example of what Kuhn would take to be happening for the last 100 years in physics?
Yes, though he may have said that those are examples of anomalies, and whether those are crises, it's a matter of the amount of those anomalies and their strength. So it's up for a debate whether this particular thing was a crisis or not.
I see. The crisis is sort of like an epistemological thing, whereas the anomaly is something that's being a new thing that's being observed. An anomaly is a new thing that's being observed, and then if there's enough of those, that can actually lead to a crisis and a paradigm shift, according to his view.
So problems arise, they gather, they grow in significance, and after some time, there may or may not come such a person as Copernicus who will propose a solution. And of course, he will be resisted mainly by old scientists, while the younger scientists will be attracted to the new approach. And Kuhn says that ultimately the old ones will simply die out. So
it's not that they'll ever be convinced. They'll just die, and and their biases just won't be influential anymore.
Not to say biases, because Kuhn would very much want to resist calling them in this way, but let's say their opposition to this, they will simply die out. And if the new approach is successful in solving problems, then it will be adopted. And in terms of dying out, it's worth pointing out that Kuhn often likens the history of science to evolutionary process, where we have speciation, which develops in new kinds of fields, and we have that survival of the fittest in terms of theories. And so we have a crisis, and that crisis is then resolved, for example, by Copernicus, and then people go back to simply developing that approach, and then the cycle may repeat or may not repeat itself. It's a contingent issue.
Interesting. So that's his overall view. Now, how would you contrast Kuhn's view against the inductive method? Now, what's interesting here is what you've described here doesn't seem to include a method, actually. So let me just ask a follow-up. Does Kuhn have a particular scientific method, or is his theory purely descriptive, not normative?
The thing with Kuhn is that he had some ideas about, let's say, classical way of doing philosophy of science, because usually people doing philosophy of science have been trying to come up with some norms of scientific thinking. And Kuhn has some very limited ideas here, but mostly he wasn't interested in those. However, the important thing to mention here is that Kuhn died while writing his last book, which was divided into three parts. The first part was focused on history, the second was focused on psychological research on concept formation, and the third part was supposed to be philosophical. It was supposed to tie all those things together. And this book, the remnants of that book in an edited form have been published in, I think, 2023 or so. And so
wow.
neither I have read it, nor do I think this work has been properly studied to give definite conclusion here, at least by me, as to whether Kuhn developed some significant norms. However, he did set a couple of things about how science works. For example, he spoke of theory choice being guided by certain epistemic values, like accuracy, like breadth of scope, how much information phenomena does your theory explain, simplicity, fruitfulness for further research. And one could, I think, object in many ways here. Let's start with the first, which is that according to Kuhn, while those norms are inherent in the concept of science, scientists attach different weights to various components of those values. Some value simplicity more, some less, some value accuracy more than simplicity, and so on and so on. And basically, each paradigm, each disciplinary matrix has its general norms of how it approaches things. And there is no neutral paradigm-free or disciplinary matrix-free set of norms that will guide you. And so there is no method ultimately that you can use to justify scientific conclusions. Though I suspect Kuhn was less skeptical here than Popper was. This is an issue that is debated among historians who work on Kuhn. So I would say there is an inductive method, and there's one way of doing science that is right and the other is wrong. In particular cases, it's wrong to attach, it's wrong to do X and not proceed differently. And of course, skeptics will come with an objection as to how exactly that looks like. And in my research, my opinion as to how scientists should proceed in choosing their theories is that it's extremely context dependent. Proper choice of a theory is a matter of context, and it's both something that is developed further by philosophers like John D. Norton, and it was also discussed by philosopher Leonard Peikoff in his lectures in his course Objectivism Through Induction, and also by other philosophers. So, and even Ayn Rand, at least to what Peikoff said. Among the things that Rand said about induction, of which she hasn't said a lot, is that in solving the problem of induction, it's not a matter of how many swans you have seen to conclude that all swans are white. Or it's not a matter of how many people you have seen, how many people you have seen that die, it's a matter of context. It's a matter of observing things like people aging, people getting sick, changing their appearance while getting older. So, and this is my answer too, although the details are yet to be published, at least from my end, which I don't want to give away.
Right. Yeah. You don't want to give it away before it's in its final form. Your thoughts on induction. Now, getting back to Kuhn's theory of the structure of scientific revolution. So what I'm hearing from there is that there aren't significant. It sounds like there aren't significant influential ways that Kuhn actually gave us norms. But getting back to his descriptions of science, in what ways would you say that Kuhn has influenced the way scientists approach their work?
Okay, so, and this he shares with Popper. Both Popper and Kuhn influenced scientists in making them highly unconfident. Both endorsed what is called in philosophy of science a graveyard theory of the history of science. Yeah, and this theory comes back to at least 19th century, and it's basically a theory of the history of science which says that history of science is a history of abandoned theories and failed attempts to get at what is the case. And we saw that Popper saying this in his falsificationism, and we hear that from Kuhn speaking about paradigms and disciplinary matrices replacing each other and being incommensurable, as he says this. And for Kuhn, history of science is also a history of failed attempts as to what is the case, and we can go further into reasons why he thinks so and why he in general is skeptical about reasoning, inductive reasoning in particular. But I think there's one thing that we may say about Kuhn's approach to norms, and that is, I think his approach neglects the issue of hierarchy. The issue of hierarchy is that the structure of our knowledge is structured in a hierarchical way with some claims relying on others. And so if we are to proceed properly, we should ensure that structure is working properly, that there are no mistakes there. We should check that structure. And although Kuhn doesn't say this explicitly, implicitly there is a neglect of hierarchy in him. For example, let's notice that in the period of normal science, scientists don't question their disciplinary matrix. They are simply accepting what is being said at the time, what they have been taught. They aren't going through the history of science.
Yeah. What's funny is in practice, at least, I don't know if this was a self-fulfilling prophecy or whatever, but that is consistent with my educational experience. However, before we go any further, can you tell the audience what we mean by hierarchy here? Or what you mean by hierarchy? My own theory of induction may not use the word the same way yours does, but go ahead, let's hear your view of hierarchy, how you're using the term.
Here I'm using it in, I think, one of the simplest manners possible. Simply, it's pointing out that our beliefs are structured in a hierarchical way, with some claims relying on others and getting their justificatory force from those other beliefs somewhere else in the hierarchy. And how it is structured exactly, that's a matter of debate, which I think you get into and what you have in mind. But that's basically what I mean by using the word hierarchy.
So one simple example of what you mean by hierarchy, and this isn't what I mean by hierarchy. But one simple example of what you mean by hierarchy here is the way Copernicus's work formed part of the justification for Kepler's work, and how some of Kepler's work formed part of the justification for Newton's work. So in some sense, in order to know that Newton's work is true, you have to understand the work of, I mean, really, Greek philosophers, then Copernicus, then Kepler, etc. That's what we mean by hierarchy.
Yeah. And
I use the word a little bit differently than that. I call that issue logical order, but that's, for now, we'll just roll with this. We agree that science has this justificatory structure where some parts rely on other parts. And Kuhn, now does Kuhn explicitly argue against that, or does he simply treat the science as though it does not have that structure?
He doesn't question the simple acceptance of what's being said by scientists during the period of normal science. That's the first thing. In general, he speaks of scientists being rational, and so he sees no problem with how normal science works, and it is arguable that it's a neglect of hierarchy. The second reason why I think he neglects hierarchy is that in his own research, for example, in his last book, as far as I've read it, he simply jumps into some issue without starting from foundations. So, for example, the philosophical part of his last book is the last part. First, he does a ton of research into psychology, into history, and only then goes into philosophical issues. And it's arguable that this is a neglect of hierarchy too. So, yeah.
I see. So yeah, so you're saying there's just evidence from his work that he just doesn't think in terms of hierarchy. He just says the scientists are being rational. You know, they're being scientific. And well, but then as you said earlier, before we talked about hierarchy, talked about what we meant by hierarchy, he said that scientists don't really question what they've been taught. In order to be initiated, as scientists, they're simply introduced into a particular paradigm, and that paradigm does not prove itself to the student. The student simply shows up, he learns the math, and that's the paradigm he's in now. He learns the math or whatever it is, and that's just the paradigm he's in now. Which, as I quipped, this is consistent with the way most people learn science, in my experience. Unfortunately, this is, and as a sidebar, I'll say this is one of my main motivations for the inductive method. Is I want science to be taught by the inductive method. I want science to be taught via the actual observations and reasoning steps that allow the student to see that this is in fact true. Instead of just believing, for example, that the earth is round, the student will actually see the evidence and arguments that Aristotle made, that the ancient Greeks made, and that Aristotle solidified at the end. That allowed them to know with certainty that the earth was a sphere, and they were able to do that before shooting any space probes into the air and taking photos. So now, what is Thomas Kuhn's view of induction, if any? Does he have a view on induction? Is it important?
He has a view as to how scientific inference looks like, at least at a general level, because he may have said some things in that last book which is very incomplete, and it's a matter of debate what he says there. But one of the things that we know for certain is that scientific inference, for example, in normal science, is a matter of reasoning based on similarity. Various new solutions that are introduced in a given paradigm or disciplinary matrix, they are judged as proper or improper based on their similarity to how things have been done so far. Whether, for example, uh, things resemble Copernicus' solution to how the planetary system works, or to how Newton's of how scientist work of a given scientist resembles Newton's approach in his Principia. And he also distinguished those scientific epistemic values like accuracy, simplicity, and he said that there is no universal method of scientific reasoning. People have those values but differ in how they weigh those values. And ultimately, you can give rational reasons for a theory, and here it seems like he's not a total skeptic, but he says that ultimately you can't prove a theory. And here he simply seems to give a standard view in philosophy that you can have probability, but you can't have certainty. And while the majority of factors that influence theory choice are internal to science, like those norms, like those epistemic values, ultimately you can't say this is simply so, this has been proven. You have to force it somehow. And very often, according to Kuhn, it's simply a matter of sociological influence that a theory is accepted, even though most of the factors are internal to science.
Yeah, it just strikes me as incredibly cynical for any scientifically minded person. I mean, he wasn't a scientist, but philosopher of science, so he's science adjacent. For a science adjacent person to just say, there's no such thing as scientific objectivity. There's no such thing as like, an ethical scientist versus an unethical scientist who puts the truth first versus not putting the truth first. It's just science is just decided by these sociological forces. It's just so cynical, and it leaves no room for heroism. Which is it's just so gross. Is my reaction to this.
That's how Kuhn has been. That's how Kuhn's structure of scientific revolutions has been mostly read, saying that this is simply a matter of external influences, peer pressure, things like this. And this gave birth to such a thing as this sociology of science movement in the history and philosophy of science. And Kuhn has been very much opposed to this movement. And so, he clarifies this in his later work that this is not his position, and that the majority of factors that influence theory choice, they are internal to science. They are those epistemic values like simplicity, accuracy, things like this. But ultimately, you have to make a leap. This can give you significant amount of reasons that you have to accept a given theory, but it can't give you complete justification. And Kuhn has been very much bashed for his views on this issue, by being interpreted as a complete relativist, while he simply accepts what I think the majority of people accepted and maybe still accept in philosophy of science, namely, you can have probability, but you can't have certainty. So it can't be the case that some other factors than simply evidence decides on a theory choice. But Kuhn wasn't so radical as he made himself seem. We may hypothesize why this was so. Maybe he was simply young and excited, or wanted to make an impression on the reader.
Or didn't fully understand all the implications, all of the cynical implications of what he had laid out.
Yeah, or he changed his mind. It's debated among historians, and interpreting Kuhn is far, far more difficult than interpreting Popper.
Changing gears here. When you talked about Popper, you talked about Popper's dichotomy between discovery and proof. Popper thought that the process of discovering a scientific claim, had nothing to do with the norms by which a scientific claim should be proven. Of course, Popper didn't think anything could be proven, so that I don't even know if we're using the right language there, but maybe he didn't use the right language either. Anyway, Kuhn had this, I'm sorry, Popper had this dichotomy between discovery and proof. And you mentioned that Kuhn disagreed with that dichotomy. Tell us how.
I mentioned that Kuhn thought that theory choice is done by reference to similarity to previous exemplary solutions. So exemplary solutions are like Copernicus' solution to the problem of how bodies move, like, or Newton's Principia, Einstein's paper on gravity. So those are exemplary solutions, and scientists decide during normal science on theory choice based on whether that new development is similar to how things have been done in the past. And for Kuhn, that's simply the case of justification and discovery being the same process. So people discover something new by reference to similarity, and they believe it because of that similarity. So
I see. So it might be a rejection of a dichotomy that we also reject, but it is completely founded in this same cynical framework of non-scientific objectivity is what it sounds like to me.
it's founded in skepticism. It's founded in trying to speak purely in psychological terms and not in terms of justification and genuine evidence. And Kuhn has expressed in various places his skeptical doubts, and ultimately his problem was that scientific method and process of induction, if it were to be completely, if it were to give justification with no problems, it would have to be algorithm-like. It would have to be like deduction. So it's basically the same kind of reasoning that Popper gives. Like, if induction is to be okay, it has to be like deduction. It isn't, therefore we have various problems. And Kuhn here tries to do simply a job of a historian of science and tries to avoid speaking of reasons, evidence, because of that argument somewhere working in the background in his head.
Now, what final notes, we're going to wrap up here. What final notes would you make on Thomas Kuhn before we give our general last notes for the show?
On Thomas Kuhn, let's say some positive thing about him, namely,
okay,
yeah, we have been speaking about being positive, and all we are doing are criticizing. We are such hypocrites. Yeah, so one of the things Kuhn influenced people in a good way was that people started to imagine different worlds, so to speak. I have, for example, seen a ton of psychologists referencing Kuhn to try to do things differently, saying there are different paradigms, so let's try to define our concepts differently, let's try to do things like that. And even though another thing positive about Kuhn, although it wasn't influential, was that he is one of the rare people that starts to put emphasis on concepts in terms of how science works. And this is so especially in his last unfinished book. So I would end with that remark. If someone wants to check that out, his last book is published under the title The Last Writings of Thomas Kuhn. It's published by Chicago University Press, so if you're interested, check that out.
Yeah, that's definitely new on me. That's very interesting that we get that last work from him. I was unaware of that. Now, final notes about what we've seen. What we've seen here is that these two very influential philosophers have given scientists no effective guidance on how to properly do science, especially in physics. So it's no wonder that using Popper's hypothetico-deductive method we don't have a way of, we don't have a scientific method which is broadly understood that allows us to break out of the preconceptions that we currently have. Since we have a theory that makes correct predictions, well, what else is there? We're not able to reason to the next level using Popper's theory. And specifically, as we covered today, it's because Popper's theory does not cover the full breadth of scientific methods that actually allow us to make fundamental progress in physics. And further, what we find is that we have a sapping of ambition among physicists. The idea that well, we can't really know anything anyway. The way science is really the real, or in the case of Kuhn, the way science progresses is ultimately through this process of sociological consensus. It leaves individual scientists without inspiration and without guidance for being the next Galileo if they want to challenge themselves in that way. So here on Inductica, one of our major focuses is going to be to replace these faulty philosophies of science with an inductive method which can obtain certainty, which can give us all of the tools we need to reason about reality and to make the next step forward in physics, to reason past the flawed theories that we're currently saddled with. So those are my closing remarks on these two philosophers. Ark, I'll give you the last word on Karl Popper and Thomas Kuhn.
The last thing that I would say is that although they have been extremely influential, to a large degree they were simply entrenching beliefs that have already been there, that have already been in philosophy of science. And if you want to read more about the history of it, one of the best books that I found is a very well written. It's a book titled What is Real by Adam Becker. It's an excellent history of how philosophy influenced science, physics in the 20th century, and how physics developed in that century. And to conclude on a philosophical remark, let's notice how both Kuhn and Popper assume that if deduction is to give us justification, it has to be like deduction. It has to be algorithmic-like. So those are my closing remarks. It was a true pleasure to appear here. I think we've spoken, we have covered very good material, and thanks, man, for inviting me here.
You're very welcome, and thank you for providing a treasure trove of philosophical background for both me and my audience. So I'm sure I'll have you on again. Now, before we go, I just wanted to let you all know that it would really help the channel if you subscribed, and of course, it'll help you if you subscribe because you'll get a lot more great content like this. And you also have a chance to get a lot more excellent content by supporting Inductica on Patreon. Just go to go to patreon.com/Inductica. And for just $5 a month, you can gain access to my lecture series, An Inductive Summary of Physics. This is a 34-hour series that goes all the way from the ancient Greeks, identifying facts about the heavens, all the way to the discovery of the atomic nucleus, and it shows you every single observation and reasoning step going from the beginning all the way to that advanced scientific conclusion. So if you want to understand the general idea of how these things were actually discovered and the process that truly proves them going from observation to conclusion, then you can watch that series for just $5 a month donation on Patreon. So thank you very much for joining us, and I hope to see you guys again next time.